Okay, welcome to our second video. So in this video, we're going to talk solely about the distributive property. So the book lists multiple properties that we'll go ahead and be using while solving equations, but I would like to specifically target just the distributive property since it is a new technique that we're going to go ahead and use. And I would like to kind of focus in on. So the distributive property is a specific property. Here you can see kind of the general format that if we have some constant, A, some number, multiplied by some sort of terms inside parentheses. What then happens is we will then multiply whoever is on the outside to every term on the inside. So you can see here we would have A times B to get a product of AB plus the operation follows from whatever's inside the parenthesis of the product of AC. So what do I mean by that? So if you notice here, if I have -3 times 2 plus x, so notice this -3 is kind of trapping everyone inside the parentheses, in this case 2 plus x. Well, remember when there's no space between any terms, that implies multiplication. So the way we go ahead and undo this parenthesis and then would be able to continue start combining any like terms if need be, is again, we just want to go ahead and multiply the term out front to everyone inside the parenthesis. I cannot stress that enough. So we would have -3 times 2, that would be our first term, whatever that product is, plus the operation follows from within the parenthesis, and then I would distribute -3 times x. So that would be -3 times x, which we'll go ahead and simplify. So there could be a million terms inside this parenthesis. That -3 is then going to be distributed to everyone inside the parentheses. So sometimes these arrows are super helpful, but again, that's the biggest thing. You have to make sure to distribute to every term within the parenthesis. So once we multiply -3 times 2, we get a product of -6, and then we have -3 times x, which is a product of -3x. So this would be the finalized answer from distributing. Okay, let's do some examples together. So apply the distributive property. So the reason why I want to talk about the distributive property in depth is because it's a technique given in some equations. So it'll be if you have an equation given, it might be that the first step that you have to do is use the distributive property. From that point on, you can combine like terms and go on, so on and so forth from there. But that's why I kind of just want to talk about in depth solely the distributive property. So if you notice, this 3 is blocking everyone inside the parentheses. So what are we going to do? We're going to distribute it to every term inside the parentheses. So then this becomes 3 times x plus, notice the operation follows, 3 times 4. Well, now we can go ahead and simplify. 3 times x is really just 3x plus 3 times 4 is 12. And that would be our final answer. And notice in this case, 3x plus 12, those are not like terms. One has a variable, one does not have a variable. So that is as far as it goes also with simplifying purposes. Okay, so next example. Notice now we have 3 terms inside the parentheses. So the 2 is going to be distributed to all 3 terms. So that implies that we'll have, well, let me get my parentheses, or let me get my arrows. 2 times 3y, 2 times -5z, and 2 times 1. So what does that look like? Again, I'll have 2 times 3y first, minus 2 times 5z, plus 2 times 1. Well, 2 times 3y, I will then just have 6y. I go ahead and multiply those together. -2 times 5, well, that is -10z. And then lastly, plus 2 times 1, that gives a product of 2. And again, notice there are no like terms here. One has a y, one has a z, and one's a constant. So that is as far as our answer needs to go. So again, all we're doing is just doing some multiplying. And again, you'll notice when we solve equations, where will that really come in handy? This one, part C, this is a very popular one. So this is one that you could probably guarantee see on the midterm type of sort of thing. I like to give these kind of problems because it's deceiving and it really kind of tests someone's knowledge. Notice I just have a negative sign here. Well, what does that mean? Well, that negative sign is secretly a -1. Many people will see this and just go straight to this because they don't necessarily see some explicit number like how we did in the other examples of 2 and 3. Well, there's still a -1. I still have something to distribute. That negative is trapping every term in the parentheses. So in order to free the parenthesis, I have to distribute this negative to everyone inside the parentheses. So please be cautious with this example. So what does this look like? Well, I have -1 times -4a. I'll just write it like this now for practice. Well, then I'm also going to have -1 times b. I'm going to put parentheses because of the signs. And then I have -1 times 3c. So again, there will be a change. So please be careful. There's still something outside that parentheses. So what happens? Well, notice this -4a that I had stuck inside the parentheses. Now I have a negative times a negative. So it becomes +4a. Then I had just b in the parentheses. Well, now I had -1 times b. So then I get -b. And then lastly, I had just 3c. But again, notice now I'm multiplying a negative to it. So now I'm going to have -3c. And that is our final answer. So please be cautious with this example. If there is something outside that parenthesis, you're going to have to distribute it, even if it is just a sneaky negative. And that is it. We're going to go ahead and move on to, I'm not sure right now, and we'll see in the next video together.